Hello, this is Elizabeth Pluswick, and today we're going to look at variable costing, fixed costing, and how it changes with the type of production, and how contribution margin can contribute to profits. So we start here with an example of a retail industry with low profit margin per product, so it needs to sell a high volume of products. Selling price is $100 each. If variable costs are $99, then we have contribution margin of $1 per unit. Okay, then if fixed costs are $1,000, we need to sell 1,000 units in order to just break even. With the formula here, fixed costs in the numerator divided by selling price per unit minus variable cost per unit leaves $1 of contribution margin per unit. That equates to 1,000 units being sold to just reach our break-even point. No profit, no loss. Where contribution margin in total, $1 contribution margin per product times 1,000 units sold just exactly covers the fixed cost of $1,000, leaving no profit, no loss. Let's compare that to an industry, again a retail industry, but it has higher margin, higher contribution margin per unit sold, so a lower volume of products are needed. Same example here with the selling price, $100 per unit, but variable costs now have gone down to $60 per unit, leaving contribution margin of $40 for every single unit produced and sold. What that means then is how many do we have to sell? Fixed costs again are $1,000. Now we see we only need 25 units in order to just break even. Again, $1,000 fixed cost in the numerator divided by per unit contribution margin of $40. Sales minus variable expenses per unit equals contribution margin. Leaves us with 25 units only need to be sold when variable costs have gone down from $99 now to only $60 in this example, leaving $40 contribution margin per unit. We only need to sell 25 units to just break even. All right, so what happens now then if we sell more than 25 units? Every additional unit sold after that break-even point is reached provides the company with $40 more of additional contribution margin, which goes straight to bottom line profit. In other words, after the break-even point is reached, as far as units sold, every additional unit sold, bottom line profit will increase by the same amount of contribution margin per unit. So in this case, $40 per unit is our computed contribution margin. So the 26th unit will give the company $40 of contribution margin, which means $40 of additional profit because all the fixed costs have already been paid. All right, let's look at an example now of a manufacturing company that's highly labor intensive. The number of units produced is on the x-axis, and dollars, either sales dollars or cost dollars, are on the y-axis. I've plotted here our fixed cost line. Fixed costs are fairly low because this company is highly labor intensive, and most of the costs are variable. Our total cost line starts right at where the fixed cost line is plus variable costs. So the total cost line starts at that point, not at zero, but at the fixed cost line. Total cost then is signified by this red line, total cost 1. And our revenue line, shown in green, starts at 0 because if you sell 0 products, you have 0 revenue. So it starts right there at the origin and then goes up. Here's our revenue line. As we sell more units, we have more sales dollars. And you can see the break-even point is right at the point where the total cost line and the total revenue line intersect. That's our break-even point. At that point, no profit, no loss. If we sell more units than that, produce and sell more units than that break-even point, total revenue will be higher than cost and will be in a net income situation in our company. If we produce and sell less than the break-even point, we'll be in this area, and that is where the costs are greater than the revenues, so we would be in a net loss situation. if we're producing back here lower than the break-even point. So what happens now if the company decides to automate the process and they purchase a new machine that will do some of the labor previously done by a person? Then what happens? So what we would do now is draw a new cost line. Our fixed costs are going to go up because we have more depreciation associated with new machinery. So fixed costs are increasing. We have a new total cost line. We're going to assume for a second that variable costs remain the same. So our variable costs start right here and has the same slope as it previously did. So our total cost line 2 with new fixed costs plus variable costs goes up like that. And our break-even point is again where the revenue line and the total cost line cross. So our break-even point now has gone up to this number of units. So if we put in a new machine that has additional fixed cost, like depreciation, and make no other changes, then our break-even point will increase quite a bit. If engineers are designing a solution to achieve faster production with more output, this is what you would have a higher break-even point because of the higher fixed costs in the new machinery. You need to justify more throughput because you're actually increasing costs of the company. Now, if you can lower variable cost and bring the slope of this total cost line down, so variable costs become less, this total cost line comes at a lower slope, then the break-even point will go back a little bit to here, to this point, and then you don't have to produce and sell quite as many units. Again, the fixed costs increase significantly in this example, so we need to either reduce variable costs or realize that we're going to have a higher need for production and sales in order to achieve an area that is, again, in the green, where the revenue line is greater than the new cost line. And that's a summary of how changing the fixed cost increases break-even point.